Hi there, friends. Welcome to GeekOut Podcast. I'm Satish Mehta, and yes, I'm that person who gets legitimately high talking about geeky things like AI chips and silicon architectures. Today, we're diving deep into AWS Trainium3, Amazon's latest weapon in the AI chip wars. And folks, this thing is spicy. Amazon just pulled a classic Amazon move at their annual reInvent conference. They announced Trainium 3 and get this, they casually dropped that Trainium 4 is already in the works. It's like announcing you are releasing the iPhone 15 while mentioning, by the way, iPhone 16 is cooking in the lab too. Talk about flexing. So buckle up, grab your favorite beverage, and let's geek out together. Before we dive into the technical wonderland of Trainium 3, let's do a quick level set. We're in the middle of an AI arms race right now, and the ammunition? Specialized computer chips. You know how your regular laptop has a CPU that's like the brain of your computer, your PC that does everything? Well, CPUs are totally adorable for spreadsheets and cat videos, but for AI training, they are like bringing a bicycle to a Formula One race. You need specialized silicon called GPUs or graphical processing unit that are basically math crunching monsters. So here's who's playing in the high stake game. We have Nvidia, the 800-pound gorilla, in the room. They have got their H100 Hopper chips and the new Blackwell series. That everyone's fighting over like they are Taylor Swift concert tickets. Seriously, companies are practically begging for these things. Then we have Google. They have been quietly cooking with their TPUs. That's tensor processing unit. Generation 7 is in production now. Google's like that smart kid in the class who doesn't raise their hand much but aces every test. Then we have AMD and Huawei. AMD has got um, MI300 series. Think of them as Rocky of AI chips. Always the underdog, but never giving up. Huawei, which is based in China, has skin in the game with their Ascend 900 series. They are the dark horse that everyone's watching nervously. And then we have the Amazon. Amazon looked at the whole situation, scratched their chin, and says like, you know what? We're just gonna make our own chips because, of course, they did. That's the Amazon way. Enter the Trainium family, purpose built specifically for training those massive AI models that everyone's obsessed with, and it's got a cousin, Inferentia. Inferentia handles inference. That's actually running those models once they are trained. So today we're talking about Trainium 3, which Amazon announced last week at reInvent. And trust me, this is where things get interesting. Okay, let's talk about the hierarchy of this beast. This is like the Russian nesting doll of silicon goodness. You open one layer and there's another layer inside. So I'll start back from the back and start with the innermost uh, layer, and then we can build up on top of that. Yeah. So level one is neuron core V4, the tiny genius. Think of neuron core V4 as the Swiss Army knife with four incredibly sharp blades. Each neuron core has a tensor engine, which you see here. It has a vector engine right here. It has a scalar engine, and then it has got something called GPS IMD. We'll talk about this in detail, but the last one is a weird, quirky programmer that handles all the custom stuff. Yeah. Plus, each core has got 32 MB super fast memory called SRAM. Think of this as the chef's countertop where you keep ingredients while you are actively using during your cooking. Yeah. Level two is the tranium chip, the muscle. Now with this kind of chip, we are getting serious. The Trainium 3 chip itself is built on 3 nanometer technology. Just to give you some idea, like in chip manufacturing, smaller is better. It's like writing. Yeah, you can fit more words on a page if you write smaller. The world has only mastered 2 nanometer manufacturing. So Amazon's basically almost at the bleeding edge technology. They are one generation behind the absolute newest iPhone manufacturing technology, which is pretty damn impressive. Each Trainium 3 chip packs 8 neuron core V4s, which you see here. Um, it's like split across two chiplets. So each of these columns are called chiplets. Each chiplet has got 4 neuron cores, V4s. And I don't know who gave the name, but think about chiplets as mini chips working together. Then it has got 144 GB of HBM3E memory. That's high bandwidth memory. Totally fancy, fast stuff. And it has got a 4.9 terabyte per second of bandwidth. Imagine data flowing like a fire hose instead of a garden hose. Yeah. This is the actual picture of Trainium 3. You can see like this is one chiplet here, and this is the second chiplet right here if you follow my cursor. Yeah. The next one is compute blade. This is where the team gets together. Each compute blade has got 4 Trainium 3 chips. Like this thing right here is each of these are that Trainium 3 chip. So there are 4 of them here with an AWS Graviton CPU, which is the normal CPU, and then some other networking stuff that you see here. That's like 32. If you look at the whole compute blade here, it has got 32 neuron cores per server, per blade, all working together like a very nerdy Avenger team. Then you have something called Trainium 3 Ultra Server Rack. This has got 36 blades or 36 servers with 144 chips. That's like 2.56 terabytes per device. Each of these thin slice that you see here is this blade that you just saw. Yeah. I know the numbers are getting silly, and this is like the difference between a water fountain and Niagara Falls. Level 5 is EC2 Ultra Cluster 3.0, the Death Star, the Godfather, whatever you want to call it. Get this, this thing right here has got, so this is whole of data center, EC2 data center cluster. Each of these rack, each of this is like this rack is one amongst hundred thousands of those racks, and each of these are like the cluster is powering almost a million Trainium 3 chips. They are working in concert to train the biggest, baddest AI models on the planet. What about the power consumption? Let's just say the ESG and the sustainability officers at Amazon might be taking a stiff drink or maybe even looking at therapy before or after looking at the electric bill. This is the data center size infrastructure that probably has its own dedicated power station. So now let's look at the inside of the chip. It has got 4 engine factory. So this is where it starts to get really interesting. Remember those 4 engines that we mentioned in each neuron core? Let me explain them with a metaphor that actually makes sense. So think about a factory. Imagine that this is a factory with 4 different workshops. One, two, three, and four. So tensor engine, vector engine, scalar engine, and GPS IMD engine. Yeah. So workshop number 1, which is the scalar engine here, is like a speed calculator. This is like that one person with a really fast calculator who can do basic math super quickly. It handles simple one number at a time operations, element by element operations like ReLU or GLU activations. So these things, don't worry about these things. We'll talk about them in future podcasts, but these are basically the activation functions in LLMs. So this stuff boring? Yeah, maybe. Essential? Absolutely. Every factory needs someone who can do basic math. So that's your scalar engine. Now let's look at vector engine. Vector engine is like an assembly line that processes whole rows of numbers at once. It's incredibly efficient. This handles operations like layer normalization, pooling operations, softmax calculations, reductions. So these are the operations that make neural networks actually learn and work. Without this, your AI would be dumber than goldfish, maybe. The third one is Tensor, and the fourth one is GPS IMD. So let's look at Tensor Engine. Tensor Engine is basically the massive grid of multipliers working in perfect synchronization, like 1,000 tiny calculators all multiplying numbers at the exact same time. It's called systolic array. Think of it as a synchronized swimming team of math operations. This is the star of the show. This is the heavyweight champion. The reason we are all here. Yeah. This is where all the magic happens. The tensor engine crunches through matrix multiplication or matmul like nobody's business. It supports all those fancy number formats you have heard tech bros talking about, like the FP8, which is 8-bit floating point. It is smaller, faster, slightly less precise. You have FP16, which is FP16, BF16, which is 16-bit format, good balance of speed and accuracy. Then you have TF32, which is TensorFloat 32, NVIDIA special sauce. It's like having multiple languages for math. Sometimes you need to speak precisely, which is FP16. Sometimes you can speak quickly and maybe at a very high level, roughly. So that's FP8 right here. And then the fourth workshop, the GPS IMD engine, is the mad scientist. The GPS IMD engine is the quirky programmer in the corner office handling all the weird stuff, custom stuff that doesn't fit into the standard patterns of math. That's handled here. It's fully programmable and runs like a C language code. When the standard engine can't handle something, this engine says, "Hold my coffee, I got this." The beautiful thing, all four engines can work simultaneously on different parts of your AI model. It's like your four chefs in a kitchen, each working on a different course of the meal at the same time. And that's 380 in 8 tops and 190 T flops of the compute per core together. Right there. Yeah? I'll let this sink in. Let's talk about memory and data movement, because this is where the real engineering genius shows up. The SRAM versus HBM story. Let's call it the kitchen edition. We'll explain it through kitchen. Imagine you are cooking Thanksgiving dinner. Your HBM memory, that's the big 144 GB memory, is like the big fridge in your garage. Yeah. And the advantage is that it's very big. It has got tons of storage. It's far away but holds everything. The disadvantage is you're got to walk over there every time you need something. Then you have this SRAM, on chip SRAM, 32 MB per core, is like that tiny bowl right next to your cutting board on the counter. You can only fit a little bit in there, but it's right there. So you can work lighting fast. You put the ingredients you are actively using in that bowl, the garlic, the salt, the pepper. So you don't have to keep running to the fridge. That's exactly what SRAM does for the chip. It holds the data the chip is actively crunching on, so it doesn't have to keep going back to the slower but bigger HBM memory. Then we have the DMA engine, or direct memory access engine. I call them I call them robot assistants. Yeah. Um, Think of these as super efficient robot assistants that move ingredients around the kitchen while you are actively cooking. They can handle 4.7 terabytes of per second of data movement. That's insane bandwidth, by the way. They can do data type conversion on the fly, converting between FP8, FP16, and so on and so forth. They can perform simple computation while moving data, compress or decompress data inline, and do scatter gather operation, which is collecting the data from multiple places and so on and so forth. Yeah. It's like having a sous chef who can chop vegetables while walking them from the fridge to your cutting board, multitasking at its finest. HBM3E memory, the speed demon. The chip uses 144 MB of HBM3E memory with 4.9 terabytes per second bandwidth per chip. And that's a juicy industry secret. Amazon switched suppliers from Samsung to Hynix and Micron, which gave them like 70% speed boost. That's like trading in your Honda Civic for a Ferrari. Same amount of memory, way faster access. Samsung is obviously not going to be very happy about losing that contract, but business is business, baby. Okay, so how does this stack up against mighty Nvidia? Look, I'm not an Amazon or AWS fanboy, but credit where credit is due. Amazon is rapidly catching up, and they are doing it their way. Um, the Amazon basic philosophy is applied to AI chips as well. So you know how Amazon has their Amazon Basics product line. Same philosophy here. Their hardware North Star is crystal clear. They want to focus on the total cost of ownership. They don't care about being the absolute fastest chip. They care about being the best value. Performance per dollar is important to them. So key competitive advantage are, it has got longest custom silicon history. AWS has been making custom chips longer than almost anyone in the data center space. Uh, for last few years, they are focused on Graviton. They have the experience and the scars to prove it. Um, they also, you know, they also focus on like building partnership, like stock warrants equals free money. So here's a sneaky business trick that Amazon tries. They Amazon has stock warrants from their suppliers like Credo, which is a cable company. These warrants are basically equity deals that result in cost rebates on components. It's like getting your cables effectively for free because you gave the cable company some AWS stock. And then it's design agnostic. So AWS doesn't have a religion attached to any particular technology. Air cooled, liquid cooled, NVLink, UA link, custom, they will use whatever delivers the best TCO. In fact, get this, AWS is willing to license NVIDIA's NVLink for Trainium 4 if it delivers the best total cost of ownership. That's like Burger King saying that they will use McDonald's fries if they are cheaper. No ego, just business. For now, they are kind of settling for air cooled, uh, while everyone else is redesigning their data center for liquid cool. AWS can deploy air cooled Trainium 3 racks today in their existing hyper optimized facilities. No massive capex, no operational complexity, no delays. Speed to market, that's the only thing that matters to them. start making money now while the perfect solution is still being developed. Yeah, that's how Amazon approaches it, I think. So let's talk about the actual improvements from Trainium 2 to Trainium 3. This is the chips glow up moment. Yeah. So if you look at compute power, that's doubled. So 2 into MX FP8 F flops throughout. That's the main performance matrix. BF16 performance is unchanged. Same silicon area and power. Their memory capacity is doubled. 2x the increase to 144 GB HBM3E using 12 high memory stacks per chip. That's tall memory, man. And then, the memory bandwidth is 70% faster. This is huge. By switching suppliers from Samsung to Hynix and Micron, 70% increase in memory bandwidth, 9.6 Gbps, which is gigabits per second, not gigabytes, but gigabits per second. Pin speed, the highest available on HBM3E. Samsung investors, you should just cover your eyes. Then they have scale up bandwidth, which is doubled, 2x improvement with PCIe Generation 6, 1.2 terabyte per second using 144 active PCIe lanes. PCIe Generation 6 is brand new technology, bleeding edge stuff. The manufacturing node, this is the node that actually manufactures the chip. This is TCMC, the Taiwanese company, which almost has got like a monopoly of building chips and GPUs in the world. That's 3 nanometer HPC optimized process, 5% faster or 10% lower power consumption. Your choice, speed or efficiency. Packing advanced technology is the packaging advanced technology. So packaging is basically how do you fix the chip on the substrate reticle, right? TSMC has got a CoWoS, so SR, chip on wafer on substrate reticle, using organic thin film interposer. This is the same packaging tech NVIDIA uses for their top chips. Two different SKUs for different needs. NL32 by 2 switched. So this used to be like, think about it, 32 by 2 was air cooled 64 chip scale up, deploy immediately in existing data center, expected to be the majority of the volume by 2026. Whereas, so this is a practical choice. Whereas in beast mode, it would have NL72 by 2 switched, which is liquid cool, 144 chips, direct competitor to NVIDIA's GB200. For when you, and it's created when you absolutely need maximum density. Yeah, and like I said, this is air cooled NL32 is supposed to be majority of volume by 2026. So now let's look at why they made this big network pivot. Here's where Amazon made a huge architectural change that shows they are learning from real world usage. So if you look at the Trainium 2, it had 3D torus. Trainium 2 used 3D torus network architecture. Sounds cool and sci-fi, right? Like something from the Matrix. But it had problems. It suffered from oversubscription, not enough bandwidth for everyone. Bandwidth gets limited as message size grows, and definitely not ideal for MOE, which is mixture of expert models. So, and an MOE is the hot new architecture after deep mind R2 from DeepSeek came out. That's the mixture of expert. They use mixture of expert technology. Uh, So 3D Taurus, just to explain it at a very high level, is like a neighborhood where you have to drive through other people's driveway to get to your destination. Yeah, it works fine when traffic is light, but during rush hour, it's a nightmare. So the new way is Trainium 3's switched fabric. So for Trainium 3, they moved to switched fabric architecture using PCI Generation 6. Benefits are it resolves the oversubscription issues that Trainium 2 suffered from due to 3D Torus model. Um, it is better for all-to-all collectives. That is when everyone needs to talk to everyone. And it's optimized specifically for MOE models. A switch fabric is like a proper highway system with on ramps and off ramps. Everyone get their own lane, traffic flows smoothly. So chip typically gets 1.2 terabytes of scale-up bandwidth using 144 active PCIe Generation 6 lanes. That's a lot of data throughput. The three generation switch strategy is pure genius. Let's talk about that. Here's where Amazon gets sneaky smart with their three generation switch plan. Generation 1 is deploy now, so it's available immediately. Uses 160 lane Scorpio X switches, creates a multi hop topology, not perfect but good enough, and starts making money today. Generation 2, that's the upgrade coming soon, swaps in 160 lane with a 320 lane switches, full all-to-all connectivity within a rack, so all can talk to all, and better performance without changing the chips. Generation 3, the ultimate form, which is the future, it has got 72 plus port UA link switches, maximum performance and lowest latency. The final boss is this. Why this phased approach? Speed to market again. They can start selling and deploying now with Generation 1 switches, while the perfect Generation 3 switches are still being developed. Then customers can upgrade switches without replacing chips. It's like buying a gaming PC where you can upgrade the GPU later without replacing the whole system. Smart engineering and smart business. Now for the really big news. This is huge. For anyone actually trying to use these chips, AWS is making a massive software pivot, and it's about time. The main goal is adoption. Let's be clear. Historically, getting AI frameworks to work on custom chips has been a pain. AWS used PyTorch slash XLA, which was, let's just say, cumbersome. That's me being super diplomatic. XLA, which stands for Accelerated Linear Algebra, is a Google's compiler. And while powerful, it's not what most ML researchers and engineers want to use day to day. It's like being forced to use a manual transmission when you just want to get to work. So they have kind of three phases. They have phase one, um, in which you have brand new native PyTorch backend, finally, support for Torch.distributed and FSDP, which is fully sharded data parallel, and 43% BF16 MFU on day zero. That's model flops utilization, respectable for a day one launch, by the way. This means, in a very high level, this means ML engineers can use exact same PyTorch code that they are already comfortable with. No weird conversions, no learning new APIs. It just works. This is huge. Phase two, which is coming, is how Amazon starts to build a moat. It would have an open source XLA compiler for people who actually need it. It would have open source JAX stack for Google's other framework, and it would have open source and Nikki kernel language for hardcore performance tuning. Amazon realizes that they have to build their own CUDA moat, which is NVIDIA's moat. a developer ecosystem is so strong that people don't want to leave it. And critically, it has to be built by external developers, not just Amazon employees. It also wants to have a game changing interoperability. Here's something that made my jaw drop. AWS is standardizing on NVIDIA's Nixel KV cache transfer library. What does this mean? You can literally mix and match Trainium 3 H100, B200 systems in the same cluster. Use NVIDIA's GPU for one part of your workload, Trainium for another. Need H100s for inference, but Trainium 3 for training? No problem. They will talk to each other. That's like being able to use iPhone chargers with Android phone. Mind blowing interoperability. The catch is LNC limitation. What is LNC? On day zero, which is logical neuron cores, LNC is logical neuron cores. On day zero, you can only expose one or two physical cores as a single logical device, which means you can only see 36 GB of memory visible to your code. Advanced users actually love this level of control. They can fine tune exactly how parallelism works. But regular ML researchers want LNC equals 8, which would expose the full 144 GB without needing complex parallelism strategies immediately. LNC 8 is not coming until mid 2026. It's like buying a car that comes with a governor limiting your speed to 30 miles per hour until you prove you can drive it properly. The full power is there, but you need to learn some advanced techniques to unlock it, or wait until 2026 when they remove the training wheels. They also have this tool called Neuron Explorer for performance analysis that's supposedly best in class. So at least you will have visibility into what's happening. Let's talk money and strategy because this is where Amazon really shines. This is them playing 4D chess while everyone else is kind of playing checkers. So think about it: air-cooled data center strategy, which is deploy now, while everyone else is rushing to redesign their data center for liquid cooling, which means dollar dollar dollar. AWS is sticking with their hyper optimized air cooled facilities. Why? Time to market and TCO. They can deploy the air cooled NL 32 by 2 racks today in existing data center. No massive capex, there's absolutely no capital expenditure, no operational complexity of liquid cooling, no delays waiting for facilities upgrade. They will introduce the NL 72 by 2 later for customers who need absolute maximum density. But most customers, they will be happy with air cooled and which is available now. Their manufacturing strategy is brilliant. Cableless design within compute trays. Everything routes over the printed circuit board instead of cables. Why this matters? Fewer cables, fewer failure points. Faster assembly, lower cost. Better reliability, less downtime. They have 16 redundant lanes on the backplane, so they can hot swap network switches without draining workloads from the entire rack. That's like changing tires on a car while it's driving. Um, Here's where the network TCO innovation, they totally think differently. So here's where they get really clever. While competitors use 400G or 800G logical ports, AWS is using 100G by default. So you would say, wait, Satish, 100G is slower. That's bad, right? Wrong. By using smaller, cheaper switches and copper cables instead of expensive optical cables where possible, they can build absolutely massive networks more cheaply. The math, let's do that. Use copper cables to top of the rack switches, minimize expensive optical links, deploy smaller, cheaper 100G switches, build a 3-year network architecture, three-layer network architecture, and result connect over half a million plus GPUs on 12.8T switches. That's half a million GPUs networked together at lower cost per port than competitors using fancier switches. Remember those stock warrants from the suppliers? This is their secret weapon. They effectively get rebates or components by giving suppliers AWS stock options instead of pure cash. Credo cables effectively free via stock warrants. That's not a typo. That's free because the warrants are worth enough to offset the cable costs. The bottom line, performance per TCO dollar is the most important metric, and AWS has optimized this better than anyone. Not the fastest raw speed, but the best bang for your buck. And in the cloud computing business, that's what actually matters. So, why should NVIDIA worry? What's the final verdict? Let's cut through the hype and marketing and let's talk real. Trainium 3 is a very serious contender. I'm not saying it's going to dethrone NVIDIA tomorrow or NVIDIA should absolutely be worried. Uh, it doesn't need to panic, but definitely it should be sweating. Why NVIDIA should worry? So, what's the final verdict? Let's cut through the hype and marketing and talk real talk. Yeah. Trainium 3 is a very serious contender, and I'm not saying it is going to dethrone NVIDIA tomorrow, but NVIDIA should absolutely be worried. Not panicking, but definitely sweating. Why NVIDIA should worry? This isn't just about raw specs, it's the whole package. Strong performance per TCO, not the fastest, but the best value. Rapid time to monetization, air cooled SKUs, ship now. Native PyTorch ecosystem play. Finally, Amazon is fixing the developer experience. Switched fabric for MOE models, optimized for modern AI architecture, willing to use competitors' tech. They will even license NVLink if it's best solution. Who should consider Trainium 3? If you're building, um, if you're training frontier models or paying the NVIDIA premium, um, those H100s aren't cheap, obviously. If you're running on AWS anyway, comfortable with bleeding edge technology, willing to work around short term limitations, this is the chip for you. Definitely watch out for LNC, 1 by 2 limitation until mid 2026. Only 36 GB will be visible memory initially, and software ecosystem is still maturing. So it's getting better, but it's not as mature as CUDA. It's also limited to AWS. Can't take these chips to Azure or GCP. The competitive landscape is NVIDIA is now facing serious competition from multiple angles. AWS with Trainium 3, Trainium 4 is coming. Google with TPU version 7, V8 is in development, and AMD with MI300 series, MI400 is coming. Plus, Trainium 4 is already announced with options for both UA Link and NVLink and networking. Amazon's keeping all options open. This is no longer a one horse race. The AI chip market is getting genuinely competitive, and that's great for customers. Competition drives innovation and keeps prices in the check. So, what are the key takeaways? All right, friends, let's wrap this up with key takeaways. If you remember nothing else from this episode, remember these five things. One, they have a cutting edge silicon, which is 3 nanometer chip technology, 144 GB HBM3E memory, 4.9 terabytes per second bandwidth. This is serious premium hardware. Two, modern architecture, a switch fabric architecture specifically optimized for MOE models. Those mixture of expert models that everyone is using now, Trainium 3 is built for them. Two, 2x scale up bandwidth with PCIe generation 6. It also has a native PyTorch support. Finally, building the developer mode the right way, interoperability with NVIDIA's hardware via Nixel. Yeah. And ruthless TCO optimization from silicon design to data center deployment, air cooled strategy for immediate deployment, every decision optimized for cost effectiveness. So to me, like finally it has got this deploy now. No focus on liquid cool for now. Like just do air cooled another 32 by 2, which are ready in existing facilities. No waiting for facilities upgrade. Start monetizing immediately. The big picture is Amazon is playing the long game and they are playing it smart. They are not trying to out Nvidia in the GPU game. They are building exactly what they need for their own massive AWS infrastructure and offering it to customer at a compelling price point. They are willing to be pragmatic, use competitor tech if it's better, deploy good enough solutions now instead of waiting for perfect, optimized, relentlessly for TCO. Like that's their game plan. So that's it for today's deep dive into AWS Trainium 3. We covered the competitive landscape, the multi level architecture from neuron core to ultra cluster, the 4 engine compute design, memory systems, and data movement. We talked about the software improvements, discussed the TCO optimization strategy that Amazon is using, and why this matters for the AI industry. So the AI chip wars are heating up, folks, and it's getting really interesting. Nvidia is still the king, but the throne is looking less secure by the day. Competition is fierce, innovation is rapid, and we're all benefiting from it. If you enjoy this deep dive, let me know. Hit that subscribe button, drop a comment, and maybe I'll do a follow up on Trainium 4 when more details emerge. Or we could dive deep into Google's TPU version 7, AMD's MI300 series, and maybe compare all of them head to head. The possibilities are endless, and there's so much cool tech to explore. Until next time, keep geeking out. Thank you.